Imagine this. Several missiles launch from far away. A few minutes later, they travel 20 times faster than the speed of sound. They fly out of the atmosphere. They enter the edge of space, and their target is your city. The missiles approach the target. They re-enter the atmosphere at extremely high speeds. About 1 minute later, they hit the ground. In the next few seconds, energy equal to hundreds of thousands of tons of explosives will burst. The entire city area will be destroyed in seconds. At the critical moment, your only hope is a complex machine. This machine is called a missile defense system. Can it really protect you during a missile attack? To successfully intercept a missile, you must do 3 things. Find the missile, lock onto the missile, destroy the missile. The first missile defense system in human history was the Soviet System A. This system had a pair of giant eyes. It was called the Dune 2 Long-Range Early Warning Radar. This machine was 8 meters tall. It was 150 meters long. It looked like a massive dam. Its job was to find the location of the missile. It could detect a target within a range of 1,200 kilometers. When it spotted a missile, it would react immediately. It pointed out the general direction of the target. The error margin was less than 1 kilometer. It also calculated the flight altitude and initial speed of the missile. Then, it sent these preliminary data to the control center. At this exact moment, 3 other radars began to work. They were 4.65 meters in diameter. They received the data from the center. They locked onto the missile from 3 different angles. This time, the location error was reduced to less than 5 meters. Based on this highly accurate data, the system calculated the flight path of the missile. It also calculated the best interception route. Then it sent commands to the launch pad. Finally, the interceptor missile followed the radar guidance. It rushed towards the incoming threat along the set path and destroyed it. However, in the 1960s, all of this was almost unimaginable. At that time, just taking the first step to find the missile was almost impossible to complete. Radar technology back then was already quite mature, but it was mainly used to detect planes. Finding a missile on a radar was much harder than finding a plane. During World War II, German bombers had a radar reflection area of about 10 square meters, but the V-2 missile only had a reflection area of 0.1 square meters. This meant the radar signal strength of a missile was only 1% of a plane. Even worse, the flight speed of a missile was much faster than a plane. The time left for the radar to catch the signal was very short. To find a missile, the detection ability of the radar had to be dozens of times higher than the most advanced anti-aircraft radars of that time. Also, people had very limited understanding of missiles at that time. Even for professional missile technicians, their knowledge focused mainly on how to launch and how to hit the target. As for trajectory tracking technology, which was the core requirement for missile defense, almost no one studied it back then. People did not even know what a missile warhead looked like on a radar screen. Therefore, many senior experts doubted if a missile defense system was truly feasible. Even the famous manned rocket expert Korolev publicly opposed it. He believed it was impossible, both then and in the future, to build an effective missile defense system. To make matters worse, missile data belonged to the highest level of secrecy. Missile experts were very cautious with these materials. They even refused to provide key data to the Missile Defense Research Team. At the critical moment, the Design Bureau 30 responsible for the research came up with a very direct solution. Since they did not know the flight path of the missiles, they decided to launch more missiles and see what they actually looked like on the radar. Under the command of their leader, Kisunko, the team built 2 experimental radars. They placed them near a missile test site in Kazakhstan. Over the next year or so, these 2 radars stared closely at the missiles in the sky every single day. They recorded the signals received by the radar. Then they compared these signals with camera footage and data sent back by sensors inside the missiles. They analyzed the radar signal features of the missiles bit by bit through repeated observation and comparison. The team finally drew a complete radar feature map. Finally, in 1957, the radar successfully tracked an R-2 missile in the air. Based on this exact data, engineers further developed more advanced equipment. They successfully built the Dune 2 Long-Range Early Warning Radar. It could spot a missile trail from 1,000 kilometers away.